More than 53 million tons of municipal solid waste is produced in Mexico every year. In Mexico City alone, over 20,000 tons of waste is produced every day, which is enough to fill the country's largest stadium within a week. To worsen the waste problem, a lack of proper waste management services leads to the open dumping of waste. The World Bank estimates that 21% of all municipal solid waste in Mexico ends up in open dump sites. However, the former Mexican Secretary of the Environment suggests that this percentage is actually closer to 70%. The practice of open dumping pollutes the environment, which also has negative impacts on public health. For this reason, it is important that the amount of open dumps in Mexico is reduced, and that investment in new waste facilities is made. Therefore, our synthesis project is focused on developing a strategic approach for site selection of waste facilities in Mexico. We worked together on this project with our client 52 Impact and supervisors Edward Verbrey and Bastiaan van Loenen.
Hello, my name is Maurits. I work at 52 Impact, a company based in Rotterdam, where we use satellite data technology to monitor what's going on in the region and use that information to help businesses become more sustainable. In the last couple of weeks, we had the fortune to work with 6 very dedicated students on a project for one of our clients, a beverage company based in Mexico that aims to reduce their waste production and the impact waste has on the environment.
Based on the task provided by 52 Impact, we formulated the following research question. What are the weak spots in the current waste infrastructure network in Mexico? And based on this, where should strategic investment be made to improve waste disposal? First, let's start with a small background to waste management in Mexico.
In Mexico, municipal governments are responsible for the collection, transport, and final disposal of municipal solid waste, which is waste generated by households, offices, markets, and other non-industrial sources. 84% of the Mexicans have access to waste collection services. This percentage varies from state to state and is the lowest in the southern regions of the country. To stop the illegal methods of waste disposal, waste collection services should be improved. Also, the open dumps, which are currently the majority of waste disposal sites, should be closed and replaced by sanitary landfills to reduce the impact on the environment and the public health. An important aspect of constructing a sanitary landfill is selecting the most suitable location for the waste facility.
This leads us to our research approach, which aims to find the best place for investment in new waste facilities. It consists of 2 parts. Firstly, we start by determining the weak spots in the current waste disposal infrastructure. Then, we focus on the weak spots in more detail and develop a spatial decision support system to select suitable locations for new sanitary landfills. We will now explain each part of our methodology in more detail, starting with the weak spot detection.
What is weak spot? Weak spots is region that should be prioritized in waste infrastructure improvement and investment. To detect weak spot, we first collect relevant data and split them into 2 groups, direct and indirect factors. Direct factors relate directly to the waste problem. For example, the capacity of sanitary landfills and the waste collection rate. Indirect factors might relate to the waste problem. They are mostly socio-economic factors, for example, population density and poverty rate. We perform spatial analysis on the direct factors to study the spatial distribution of waste facilities and the relationship with the waste disposal sources in Mexico. Then, we perform statistical analysis to determine which indirect factors were related to the waste problem. One of our findings was that the gap between the total amount of disposed waste and the capacity of the sanitary landfills is quite large, and the areas of deficiency spread throughout the country. Therefore, using this factor alone cannot strategically detect the prioritized spot for investment. On the other hand, the indirect factors showed an interesting link between the lack of proper waste management in the rural areas and poor areas in general.
The dataset of direct and indirect factors were then normalized to a range from 0 to 1. And as a last step, we checked the datasets for multicollinearity, by calculating the variance inflation factor between any two factors. We checked which two factors show a VIF higher than 4 and then removed one of the two factors. This is done in order to take care of redundancy. For example, the percentage of illegal disposal has a very strong correlation with the percentage of people with access to a waste facility, so we cross one of the two out. From the refined set of factors, we grouped them according to 3 scenarios and performed the weighted overlay method to produce the maps. In the first scenario, we add up all the normalized values of the directly related factors only and use equal weighting for all factors. The second scenario, we do the same for the indirectly related factors. This map could be of use if there is little data about waste management available and can tell us more about the characteristics of weak spots. The third scenario focuses on factors that are suitable for landfill investments. Since landfills generally work better in densely populated areas, we add more weight to those factors. The map of the first scenario is used as the input for the selection of potential locations of new landfills. Areas with the lowest score are detected as weak spots. The weakest spots in the current waste disposal infrastructure of Mexico are located in the south, mainly in the state of Oaxaca, which is one of the poorest states.
After we got the result of the weak spot from the previous step, then it comes to the second part of our methodology. The aim of this part is to find the potential location for new sanitary landfill based on weak spot municipalities. Since many factors need to be taken into account to find the most suitable location, we developed SDSS to help the decision-making process. So, what is SDSS? In short, it is a computer-based system combining spatial data and decision logic to aid the decision-making process. And this is the steps of our SDSS methodology. First, we select weak spot input by categorizing the weak spot municipalities into urban, suburban, and rural. The siting of new sanitary landfill is only appropriate for more densely populated areas. Therefore, we only select the urban municipalities for the site selection suitability analysis. We select the criteria based on literature studies and Mexican legislation. In total, we collected over 30 relevant criteria. To reduce the complexity of our SDSS and due to the limitation related to availability of data, we choose to select 7 criteria for the final SDSS. After that, we classify the criteria into 2 main types, constraints and decision criteria. After the selection step, we assign weights to the 4 decision criteria in order to specify their importance. We choose to implement 2 weighting schemes for the analysis. First, equal weighting, and the second is AHP weighting. AHP is analytic hierarchy process based on pairwise comparison of criteria using a scale of importance ranging from 1 to 9. And this is the weight based on AHP calculation for 4 decision criteria. The next step is to prepare suitability maps for all criteria based on the zones and scale values. As the example, area less than 500 meters and more than 10 kilometers from the settlement were assigned a scale value of 0. The remaining area between these 2 constraint zones was split into 3 zones with scale value decreasing with distance from the settlement footprint. We do this for all criteria based on the zones and scale values. Then, the suitability maps were rasterized to perform an overlay analysis. So, we can see that in order to get the potential location from each weak spot municipality is pretty long and complex. Therefore, we built a QGIS plugin to automate the process. By using this plugin, the user can independently input the weak spot location and also the criteria layers by themselves. And the plugin will automatically run the whole steps and produce a raster map with scale from 0 to 10. And this is the result from the plugin with overlay score starting from 0 as excluded area into 10 as the best suitable area.
So what is the significance of our results, and what are the main limitations?
First, in general, according to our weak spots map, we think that the waste infrastructure in Mexico should be improved. And also, we provided 3 scenarios for investors to choose based on their preference. Finally, we think that our approach and our selection of criteria can be used for other areas or countries that have the similar development background like Mexico. As for SDSS, we think the most important aspect of our result is to show which area is suitable and unsuitable for landfill sitting based on Mexican legislation. And also, we find an interesting application of our plugin. That is, we can test if the current landfill is comply with the legislations. However, due to the limited time and the working context, our product and our research have some limitations. For example, in weak spots detections, the data sets for generate the factors is not always in the same scale. Some are in the state levels and some are in the municipality levels. And also for SDSS, we think we can include more criteria in our research because it can make a better decision makings. And overall, for our approach, we think we can include more expert opinions to help us to do the better decision makings.
To conclude, the waste management problem in Mexico is complex, making it difficult to know where to invest in new waste facilities. Our group has developed a strategic approach, which starts by detecting weak spots at the country scale and then zooms in to pinpoint where new waste facilities could be built. We hope our results will be able to contribute towards reducing waste mismanagement in Mexico and ultimately reduce the risks to the environment and public health. Thank you for listening. Feel free to ask us any questions.
Super. Again, an impressive video by this group of students. Of course, we also have questions. The first question is by the supervisor of the project, Edward Verbrey. First question, it's your synthesis thesis, geomatics synthesis project. Can you explain the role of geomatics in spatial decision support systems? And would you recommend to have a course in this in a geomatics curriculum?
Yeah, maybe I try to answer that question. Yeah, for our team, it's quite a special case because we're dealing with multidisciplinary. So we're not only dealing with a spatial dataset, but also non-spatial dataset. Like if you see from the video, we did a lot of statistical analysis as well. That's why I think SDSS is quite important, especially when we're dealing with the government. To find a potential location, we're not only consider about the spatial, but also the regulation. So if we can have that course, maybe it will be nice.
It's a real addition to the curriculum, you're saying, basically.
Yeah.
Okay, let's see what the other. The other question is by Peter van Oosteren. In more and more countries, waste is considered to be renewable, both in the resources and the materials. Do you have any clue if this already is the case in Mexico?
Well,
and whether it is going to be economically feasible?
Well, they did try to, for example, construct a waste incineration plant so that the waste will result in energy. However, in Mexico, you also have an informal sector consisting of waste pickers that also used different elements of the waste for to recycle it, to sell it. And those waste pickers actually protested against the incineration plant, which resulted in it not being, being constructed. So although they do have those plans, they do not realize because of the informal sector.
Very good. And then another question by Peter van Oosteren is about the size of the country. Mexico is big, but what was the resolution of your rasters? And did you use multi-resolution detailed grids?
Yeah, Quinn?
Yeah, okay, I can answer this question. For the country scale, we do not use a raster, but we use the shapefile of the municipality level, and we attach the spatial and non-spatial data to that shapefile. So the resolution is not a problem.
Yeah, and also basically that's why we determine the weak spot first, because right now we're working with municipality level for the plugin, and the running process it's still quite long. So because we need to rasterize the dataset first and then to do multi-buffer, yeah, many stuffs. That's why I think also the size of the weak spot is important to make the plugin run faster.
Very good. Oh, Vera's both doing the multitasking, answering questions and answering them in the chat box. Another question by Edward is well, basically on the lessons learned on identifying what a real project scope should be, and well, you can read it there. How long did it take you to understand what the project was really about, and what was your role in this? Can someone elaborate on that?
Shall I answer that?
Yeah.
I think in the beginning we had trouble understanding what the client wants, and also to make it related to geomatics.
Vera, you're muted, I think.
Am I?
No.
Oh, okay. So yeah, we had some trouble with that, and it took us a couple of weeks to get a methodology that actually worked. And what was the second part of the question? How long? Yeah, I think.
What was your role in this project?
I think so. In our in our geomatics knowledge that we have now, we didn't have any knowledge about SDSS, for example, or also like statistical analysis that we did. So I think that was difficult in the beginning, but we learned a lot from it.
And was anything from the curriculum useful for you to? Could you apply any knowledge from the curriculum to this project?
Yeah, I think a lot of courses. We did bits of Python coding. We did a lot of cartography, also some legislation. So yeah, I think it was useful.
Quite a nice mix of courses that were integrated here. Then we have a question by Dong Liangpeng. How many waste facilities do you anticipate to build at each site?
I can answer this one. This isn't really something that we had the chance to look into, to be honest. Ideally, if we would have had a bit more time, it would have been interesting to consider how much waste was being produced by a municipality and its surroundings, and then base our spatial decision support system on that. But time constraints didn't really allow that kind of analysis. Yeah, does that answer your question?
So yeah, well, the question that's then the next question would then be how much would that cost, and is it feasible to advise something like that to the Mexican government? And a question I have, and probably it's going to be the last question. You're using the data from the government of Mexico, I think, primarily, and that's of course including the, let's say, the official information about waste dumping and the amount of waste that's been stored in the sanitary landfills. There is also another factor, let's say, burning waste. Do you think that by improving the access to waste facilities would decrease the amount of waste being burned?
Yeah, if I can answer the question. Rohit?
Can I answer this? Yeah.
Yeah, sure.
Well,
Go ahead.
The thing is, our project focused mainly on sanitary landfills for urban areas. Literature research has shown that most of the burning happens in rural areas. So I do not think that it will decrease the amount of open burning, but we did include in our report other methods for rural areas to decrease the amount of open dumping, open burning, and burying of waste. So they are able to apply these methods to do so.
Super. Thank you very much for answering this question. And having said that, is your method also applicable for other situations in other countries? Or similar situation in other countries? Or is this the legislation, for example, in Mexico so specific that it can only be applied to the situation in Mexico?
We do that. Our approach and our selection of criteria can be applied to some areas that have similar background as Mexico, because we have like 3 different categories of our criteria. But we think for social and economy, it can be applicable for other areas. But for the legislation part, we think we have to depend on the situations of that area. Yeah.
Great. Well, thank you very much for your very nice answers. And again, there is the applause just for me, but I guess the rest will join you digitally. Then we take a break for another, let's say, 8 minutes. We will be back at 5 with the announcement of the Geomatics Thesis Award 2019. So thank you very much, Group 52 Impact, and we will be back at 5 on this YouTube channel. Stay tuned.